All right, so we have a velocity versus time graph for an accelerating object given below. Let's get the acceleration by getting the slope. So we have a point here and a point here. So we have 5 and 50, 0 and 0. And for part A, the acceleration is simply going to be 50 minus 0 over 5 minus 0, and we're getting 10 meters per second squared. The velocity at 0, we read it off the graph, is 0 meters per second. The velocity at 5 seconds, we read that off the graph, and it's 50 meters per second. Now, assuming the position is 0, how far does it go after 3 seconds? So we could do x is 1/2 at squared plus v naught t plus x naught. We plug in our numbers. X is 1/2. We got our acceleration is 10 in part A. The time is 3 seconds squared. V naught is our initial speed, and we got that already as 0. The time is 3. Our initial position is 0. So we end up getting 45 meters as the distance covered. So that's part D. For number 7, let's just go ahead and take a look at it. So we have buggy A starting at the 200 centimeter mark, rolling backwards at 40. That's buggy A. Buggy B, let's write down its equation. Interesting, its equation says that it is rolling forward at 10 centimeters per second. All right. Now we're going to determine when and where they meet again. Okay, for part C, set them equal. Negative 40t plus 200 is negative 10 times t. Sorry, is plus 10 times t. We'll add 40t to both sides, and we end up getting 200 is 50 times t. We'll divide both sides by 50, and we'll get that the time elapsed is 4 seconds for them to meet. Now we can also get where they meet by plugging back in. So we can say x is 10t, which is 10 times 4. They meet at the, at the 40 meter mark. Now what we want to do is we want to actually draw a graph and label it to see that our graph confirms the answers. So let's just see. So 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds. So 1 second. Sorry, so 1, 2, 3, 4, 5, 6, 7. This is the time in seconds. And then here we're going to have the position. And I believe the unit of that is it meters? Centimeters. There we go. So let's just shrink this a little bit so we can actually see it better. And we have here so that didn't work. Let's try that again. Whoops. Again, just make sure we're getting it through the lines as we need it. And I'll tell you how I'm counting in a second. So this is going to be 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200 centimeters. Now let's look at each buggy. We've got one buggy. It starts at 200. It's buggy A. Buggy B will make this color. So buggy A. Let's draw its plot. It starts at 200 and it goes every 1 second. Its speed reduces by 40, so 20, 40. 1 second, 20, 40. 1 second, 20, 40. 1 second, 20, 40. 1 second, 20, 40. Awesome. And let's just go ahead and draw a line here. Whoops. Oh, close enough. I'd love it to continue, but clearly it doesn't want to do what I want it to, so we'll just leave it like that. Now, for the other, it is going forward at 10 centimeters per second, and that's buggy B. So let's draw its plot. It starts at 0. At 1 second, it's at 10. 2 seconds, it's at 20. 3 seconds, it's at 30. 4 seconds, it's at 40. 5 seconds, it's at 50. All right. Now let's see what kind of line we get here. And we'll see where these intersect. There we go. So it looks like our lines actually intersect at 4 seconds and 40 meters, which is exactly the solution to the problem that we obtained here. So we have indeed graphed this correctly. We are in good shape, and that is problem number 2.